When enzyme and substrate molecules are mixed, they randomly collide, forming enzyme-substrate complexes. As temperature increases, so does the kinetic energy of the molecules, and therefore also the rate at which these collisions occur. There comes a point at which the maximum rate of reaction is achieved, and the temperature at which this occurs is known as the optimum temperature. If the temperature continues to increase beyond the optimum, the enzymes begin to lose their three-dimensional structure and become denatured, therefore reducing the rate of reaction. Now you need to be able to recognize the graph of the effect of temperature on enzymes. It looks like this, with the peak being the optimum temperature. To explain up to the peak, as the temperature increases, so does the kinetic energy of the enzymes and the substrates, resulting in an increased frequency of collision between the two, thus increasing the rate of reaction. But beyond the optimum temperature, this continuing increase in kinetic energy results in a loss of 3D structure from the enzyme and therefore a change in its active site. If the substrate can't fit into it, the enzyme is referred to as being denatured, and this reduces the rate of reaction. Now for a look at pH. Increasing pH values are as a result of adding hydroxide ions, or OH-. Decreasing pH is as a result of adding hydrogen ions, or H+. Either of these can potentially alter the charges on the amino acids that make up the enzyme, and this can lead to the enzyme's active site changing shape because the bonding changes, for example, and that could denature it. Or it could mean that the substrate can no longer bind to the enzyme's active site, and so either way the rate of reaction is reduced. The graph for the effect of pH on enzyme activity is very similar to that of temperature, although you might notice a more symmetrical decrease in rate of reaction either side of the optimum pH. On to having a look at substrate concentration. When we change substrate concentration, we are assuming that enzyme concentration is remaining constant. Initially, increasing substrate concentration from 0 will increase the rate of reaction as the substrates randomly collide with the enzymes and the enzymes catalyze the chemical reaction. However, there comes a point where all of the enzymes' active sites are filled and the enzymes are already working as quickly as they can to catalyze the reaction. This is where the maximum rate of reaction is reached, and any further addition of substrate beyond this will not increase the rate of reaction anymore.